Good morning. Before I get started, I want to say I hope everyone's doing all right out there. This lesson is for my Integrated 1 and my Integrated 1 Honors class. This is lesson number 7 in the Solving Equations lessons. Let's just go ahead and jump right into it and talk about what our goals are. We really only have one goal. We have the 6 steps to solve any of these equations. So we've established a routine that we can follow, a sequence or an algorithm that will solve the equations for us. But what I want to focus on today is interpreting special cases when solving equations. And so what happens is sometimes when we solve equations, something goofy happens. And I want to explain to you what that means. And so there's 2 possibilities when we get a goofy situation. It's going to be an infinite number of solutions, or there's going to be no solution. Let me make that singular because it's not plural, so it's going to be no solution. So I also put up here 2 examples of a normal solvable equation that has answers. I want to talk about what the result looks like so we can compare them to both unique situations or special cases. So let me just quickly again race through, not too fast, but fast enough that we can move on to the more important part of the lesson. So again, when we're solving equations, I really do recommend that you write 1, 2, 3, 4, 5, and 6 next to the equations, representing our 6 steps to solve the equations. The first step is, can I eliminate fractions? And in this equation we can. And so I'm going to put a check mark next to 1, and then I'm going to write a 2 next to every number on the equation. The first 2 that I multiply actually eliminates the fraction. That's why we're doing this step first. So it becomes x plus 6x is equal to 42. Can I combine like terms on each side of the equal sign? I can on this side. So I have an x, I have 6 x's. So now I have 7 x's. Do I need to get all my variables to one side? No. I think I actually skipped this step. Let me go back here. Can I distribute? No. Can I combine like terms? Yes. Can I get all variables to one side? No. Can I add or subtract a number to both sides? No. Can I divide away a number to both sides? Yes. So I'm going to divide both sides by 7. And we see here that x is equal to 6. So this is an example of an equation that has a solution. A variable is equal to a number. Okay, this has what we would consider a real solution. All right, example 2. Again, I'm going to write the 6 steps. I got to remember that the second step is distribution. I made that mistake on the first one, but that's okay. Can I eliminate fractions? No. Can I distribute? Yes. So now we get 2x minus 12 equals to negative 12. Can I combine like terms? I can't put these together. There's no one on the right side to combine with, so I'm going to put an x on 3. All my variables are on this side of the equation, so I don't need to move them. Number 5, can I add or subtract away a number? Yes, I can add or subtract away that negative 12. And then I'm going to have 2x minus 12 plus 12. I owe 12, I have 12, that means I'm left with nothing. Some people stop here and say that this means that there's no solution. That's actually not the case. Equations are allowed to equal 0. Okay? They are allowed to equal 0. Normally I make a joke about how many championships have the Lakers won since 2014, and that equals 0, and there's an example of equations equaling 0, but I'm not going to pick on the Lakers anymore. But the point of this problem is I wanted to show you that equations actually could equal 0, right? If you have nothing and you're sharing it with 2 people equally, that means that each person gets nothing. Equations are allowed to equal 0, okay? Just, I can't wait for them anymore. I won't. All right, so this is just the normal equations I wanted to go through there and just stress the fact that we have a variable equaling to a number. It could be a positive number, it could be a neutral number, it could be a negative number. It's just a variable will equal to a number, okay? So let's move on to solving our infinite number solution problem. Now, with this equation, we're still going to use our 6 steps. I was going to look for a different color, but I'm not finding one that I'm sure will work. All right, so can I eliminate fractions? No. Can I distribute? Yes. So 2 times 3 is 6, 2 times 2x is 4x. Okay, can I combine like terms? No. Can I combine like terms? No. Can I get all variables to one side? Yes. So what I'm going to do is I'm going to subtract this 4x to both sides. And this cancels itself out, but it also cancels itself out on the other side of the equation. And we're left with 6 is equal to 6. Now, this is a true statement, right? And so, again, I want to talk about interpreting special cases when solving equations. So notice when I have a solution, I'm left with an x. Right here, there's no more variables. There's no more variables. And the other thing I want to point out is that we have a true statement. 6 is equal to 6. So that means that when the variables cancel out and you get a true statement, that means that we have an infinite number of solutions. And let me explain why there's an infinite number of solutions. And I want to focus specifically on this right here. Okay, so I'm going to rewrite this line of the equation, 4x plus 6. And I intentionally switch the order of these so it wouldn't be so obvious that that this side, the right side, was the same as the other side. So, you know, it could be 6 plus 4x, or it could be 4x plus 6. And so if I rewrite it like that, you see that both sides of the equation are the same, right? And so it doesn't matter what we pick for x, because no matter what number we pick for x, we're multiplying it by 4, and then we're adding 6 to it. So if I pick 1, that becomes 4 plus 6. If I pick 2, that becomes 8 plus 6. If I pick 3, that becomes, I gotta do 12 plus 6. So no matter what numbers I pick, these two sides are always going to be the same, and so that's why we have an infinite number of solutions. So when the variables cancel and we have a true statement, 6 equals 6, that means we have an infinite number of solutions. Now, you have enough to make a conjecture about what happens, you think, when there's no solution. And so I would hit pause and maybe take an educated guess based on the two examples we've seen here. And let me move this chair out of the way that you don't see so I don't fall over and go viral for being clumsy. All right, so you know, hopefully you had a time to take an educated guess about what would happen when there's no solutions. So when we have a solution, we still have a variable. Here I have no variables, but a true statement. That means an infinite number of solutions. So the variables should cancel out, and I should get a false statement. And so let's go ahead and set this up. So again, we have our 6 steps to solve. 1, 2, 3, 4, 5, and 6. Can I distribute? Yes. So this becomes 3x plus 6 plus 2x is equal to 5x minus 8. And then I can, I gotta learn my steps. Can I eliminate fractions? No. Can I distribute? Yes. Can I combine like terms? Yes. So 5x, or 3x and 2x, that's my 5x. I'm doing the math before I'm speaking. So 5x plus 6 is equal to 5x minus 8. And so if we look at this line in comparison to this line down here, the 5x's are the same, right? But on this side I'm adding to it, on this side I'm taking away. So the values, instead of constantly being the same, are going to be doing this kind of shift. And so when I do my step 4, when I subtract my 5x to both sides, what you're going to see happen here is you're going to see that my variables canceled out, no more variables, and now I'm left with a false statement. 6 equals to negative 8. That's false. And the reason why that's false is, again, if I look at this line, there does not exist a number that we know of that when I multiply it by 5 and I add it to 6 will be the same as when I multiply it again by 5, but then I take away 8. It's this part right here that's making this so that there's no solution. So again, no more variables. And then it's a false statement. It's not true. 6 does not equal negative 8. So I hope that this helps you guys to understand why some equations have infinite number of solutions and why some equations have no solutions, and what must happen when an equation does have a solution. We're left with a variable, we're left with a value, and so hopefully this makes sense to you guys. I'll see you guys later. I hope you have a good day. Bye-bye.